The minimum working clearance in front of opening doors to a 4160 volt primary to 480 volt secondary pad mount transformer is 3 feet. This clearance is essential for ensuring the safety of personnel who may need to access the transformer for maintenance, inspection, or repairs. It provides adequate space to maneuver and avoid accidental contact with energized components. The National Electrical Code, or NEC, specifies minimum working distances in Article 110.26, which addresses spaces about electrical equipment operating at 600 volts, nominal or less, and in Article 110.34, which addresses spaces about electrical equipment operating at over 600 volts, nominal. These requirements depend on the voltage to ground of the equipment and the conditions present in the working space. These conditions are typically defined as follows. Condition 1, where exposed live parts exist on one side of the working space and no grounded parts or grounded surfaces are on the other side of the working space, or where exposed live parts are on both sides of the working space and are effectively protected by insulation or other means. Condition 2, where exposed live parts exist on one side of the working space and grounded parts or grounded surfaces are on the other side of the working space. Condition 3, where exposed live parts exist on both sides of the working space and are not effectively protected by insulation or other means. For a 480 volt system which is less than 600 volts, and assuming condition 1 exists, the minimum working distance is 3 feet for voltages 0 to 150 volts to ground, 3 feet for voltages 151 to 600 volts to ground. For condition 2, the minimum working distance is 3 feet for voltages 0 to 150 volts to ground, 3 feet for voltages 151 to 600 volts to ground. For condition 3, the minimum working distance is 3 feet for voltages 0 to 150 volts to ground, 4 feet for voltages 151 to 600 volts to ground. For a 4160 volt system which is over 600 volts, and assuming condition 1 exists, the minimum working distance is 3 feet for voltages 601 to 2500 volts, 4 feet for voltages 2501 to 9000 volts. For condition 2, the minimum working distance is 4 feet for voltages 601 to 2500 volts, 5 feet for voltages 2501 to 9000 volts. For condition 3, the minimum working distance is 5 feet for voltages 601 to 2500 volts, 6 feet for voltages 2501 to 9000 volts. The working space shall not be less than 30 inches wide in front of the equipment. The working space shall be clear and extend from the floor or platform to a height of 6.5 feet or the height of the equipment, whichever is greater. Access to the working space must also meet specific requirements. There should be at least one entrance to give access to the working space. For equipment rated 1200 amps or more and containing overcurrent devices such as circuit breakers or fuses, there must be an entrance at each end of the working space. Where the equipment is located so that the entrance to the working space is not convenient, the working space must be enlarged to provide a more convenient entrance. In all cases, the entrance must be large enough to allow easy access to and from the equipment. Adequate illumination is also crucial for safety. Sufficient lighting must be provided to illuminate the working space around the transformer. This helps personnel see clearly and avoid potential hazards. The lighting should be positioned to minimize shadows and glare. Proper training is essential for anyone working on or near electrical equipment. Personnel should be trained in safe work practices, including how to identify hazards, use personal protective equipment, and respond to emergencies. Regular refresher training should be provided to ensure that personnel stay up to date on the latest safety procedures. In addition to the NEC requirements, local codes and regulations may have additional requirements for working clearances around pad mount transformers. It is important to check with the local authorities to ensure compliance with all applicable codes. Maintaining the proper working clearance around pad mount transformers is critical for safety. Failure to do so can increase the risk of electrical shock, arc flash, and other hazards. By following the guidelines outlined in the NEC and other applicable codes, you can help ensure a safe working environment for personnel who need to access the transformer. When working with electrical equipment, always de-energize the equipment before beginning any work. If it is not possible to de-energize the equipment, use appropriate personal protective equipment, or PPE, such as insulated gloves, safety glasses, and arc-rated clothing. Never work alone on electrical equipment. Always have another person present who can provide assistance in case of an emergency. Be aware of the potential hazards in the working space, such as exposed live parts, sharp edges, and slippery surfaces. Take steps to mitigate these hazards, such as covering exposed live parts with insulation, using caution when walking around sharp edges, and wearing slip-resistant shoes. If you are not qualified to work on electrical equipment, do not attempt to do so. Call a qualified electrician to perform the work. Always follow safe work practices when working on or near electrical equipment. By following these safety precautions, you can help prevent accidents and injuries. The specific requirements for working space depend on several factors, including voltage, layout, and enclosure types. The National Electrical Code, or NEC, provides detailed tables and guidelines for determining the appropriate working clearances. Article 110.26 of the NEC covers the requirements for working space around electrical equipment operating at 600 volts or less. This section specifies the minimum depth of the working space based on the voltage to ground and the condition of the installation. The conditions are defined as follows. Condition 1 involves insulated or guarded live parts on one side and grounded parts on the other side. Condition 2 includes insulated or guarded live parts on one side and grounded parts on the other side. Condition 3 describes unguarded live parts on both sides of the working space. Article 110.34 of the NEC provides requirements for working space around electrical equipment operating at over 600 volts. It outlines minimum distances for different voltage levels and conditions. These requirements are more stringent due to the increased risk of higher voltage systems. First, voltage to ground is a critical factor. Higher voltage levels require greater working distances to protect personnel from arc flash and electric shock hazards. Second, the layout of the electrical equipment impacts working space requirements. Obstructions, such as walls or other equipment, can reduce the effective working space. It is essential to maintain clear and unobstructed access to the equipment. Third, enclosure types influence the amount of working space needed. Enclosures provide a degree of protection, but personnel still require adequate room to safely perform tasks. Enclosures can be general purpose, dust-tight, watertight, and explosion-proof. General purpose enclosures are typically used indoors in environments where they are not exposed to excessive moisture, dust, or corrosive elements. Dust-tight enclosures are designed to prevent the ingress of dust. They are used in environments where dust is present, such as manufacturing facilities, mills, and grinding operations. Watertight enclosures are designed to prevent the ingress of water. They are used in environments where equipment is exposed to rain, splashing water, or hose dams. Explosion-proof enclosures are designed to contain an internal explosion without causing an external hazard. They are used in environments where flammable gases or vapors are present, such as oil refineries, chemical plants, and gas stations. The working space should also be properly illuminated. Adequate lighting ensures that workers can see clearly and safely perform tasks. The NEC requires a minimum illumination level in the working space. Access and egress are essential considerations. There should be clear and unobstructed access to the working space. The NEC also specifies the minimum size of the entrance to the working space. When equipment is likely to require examination, adjustment, servicing, or maintenance while energized, the depth and width of the working space must comply with specific requirements. The depth of the working space in a direction of access to live parts must not be less than specified in tables outlined in the NEC. The width of the working space in front of the electrical equipment must be the width of the equipment or 30 inches, whichever is greater. In all cases, the working space must allow at least a 90-degree opening of equipment doors or hinged panels. The height of the working space must be a minimum of 6.5 feet or the height of the equipment, whichever is greater. The working space must be kept clear and free of obstructions. This includes tools, materials, and other equipment. Maintaining a clean and organized working space reduces the risk of accidents and injuries. Personnel working in the working space must be properly trained and qualified. Training should cover electrical safety, hazard recognition, and the use of personal protective equipment. Qualified persons are those who have the skills and knowledge related to the construction and operation of the electrical equipment and installations and have received safety training to recognize and avoid the hazards involved. Personal protective equipment, or PPE, is designed to protect workers from electrical hazards. PPE includes items such as insulated gloves, safety glasses, and arc-rated clothing. The type of PPE required depends on the specific hazards present in the working space. Regular inspections of the working space should be conducted to identify and correct any potential hazards. Inspections should include checking for adequate working space, proper illumination, clear access and egress, and the presence of any obstructions. Regular maintenance of electrical equipment is essential for ensuring its safe and reliable operation. Maintenance should include inspecting, testing, and cleaning equipment. Any damaged or defective equipment should be repaired or replaced promptly. Emergency procedures should be in place in case of an accident or injury in the working space. Procedures should include how to contact emergency services, provide first aid, and evacuate the area. These guidelines and requirements are put in place to make sure a safe and efficient environment for working around pad-mounted transformers. By following these guidelines, electrical workers can reduce the risk of accidents and injuries and ensure that electrical equipment operates safely and reliably. Proper clearance helps reduce the likelihood of electrical shock and electrocution. It creates a safe distance between personnel and energized components, preventing accidental contact. Sufficient working space allows workers to move freely and safely while performing tasks such as inspections, maintenance, and repairs. It prevents awkward postures and reduces the risk of slips, trips, and falls. Adequate working space facilitates the use of tools and equipment. It provides enough room to maneuver tools and equipment safely and efficiently, reducing the risk of damage or injury. Proper working space is essential for arc flash protection. In the event of an arc flash, sufficient space allows workers to move away from the hazard quickly, minimizing the severity of potential injuries. Working space requirements are typically specified in electrical codes and standards, such as the National Electrical Code, or NEC. Adhering to these codes ensures compliance with safety regulations and helps create a safe working environment. Electrical safety training is essential for all personnel working near electrical equipment. Training should cover the hazards of electricity, safe work practices, and the proper use of personal protective equipment. Regular inspections of working spaces should be conducted to identify any potential hazards or violations of safety codes. Inspections should be documented and corrective action should be taken promptly. Electrical hazards should be properly identified and labeled. Warning signs and labels should be used to alert personnel to the presence of electrical hazards and the need for caution. Personal protective equipment, or PPE, such as insulated gloves, safety glasses, and arc-rated clothing, should be used whenever working near exposed electrical conductors or circuit parts. Always de-energize electrical equipment before working on it whenever possible. If it is not possible to de-energize the equipment, use appropriate safe work practices and personal protective equipment. Never work alone when working near electrical equipment. Always have another person present who can provide assistance in case of an emergency. Be aware of the potential for arc flash and take appropriate precautions to protect yourself. Maintain a safe distance from exposed electrical conductors and circuit parts. Use insulated tools and equipment when working near electrical equipment. Report any unsafe conditions or practices to your supervisor or safety manager. Following these safety precautions can help prevent accidents and injuries and ensure a safe working environment for all personnel.